The Bell 1515 was an American tiltrotor VTOL aircraft. It was the second successful experimental tiltrotor aircraft and the first to demonstrate the concept's high-speed performance relative to conventional helicopters. Development Early VTOL rotor aircraft The idea of building vertical takeoff and landing aircraft using helicopter-like rotors at the wingtips originated in the 1930s. The first design resembling modern tiltrotors was patented by George Lieberger in May 1930, but he did not further develop the concept. In World War II, a German prototype called the Fock-Achilles FA-269 was developed starting in 1942, but it never flew. Two prototypes that made it to flight were the one-seat Transcendental Model 1G and two-seat Transcendental Model 2, both powered by single reciprocating engines. Development started on the Model 1G in 1947, and it flew in 1954. The Model 1G flew until a crash in Chesapeake Bay on July 20, 1955, destroying the prototype aircraft but not seriously injuring the pilot. The Transcendental 1G is the first tiltrotor aircraft to have flown, and it accomplished most of a helicopter-to-aircraft transition in flight to within 10 degrees of true horizontal aircraft flight. The Model 2 was developed and flew shortly afterward, but it did not fly much beyond hover tests. The United States Air Force withdrew funding in favor of the Bell 15-3. The Bell 15-3 was first flown in 1955. Like its predecessors, the 15-3 had the engines in the fuselage and drive shafts transferring power out to tilting wingtip rotor assemblies. Other rotor concepts, such as slowed rotors, stopped rotors, folding rotors, and variable diameter rotors, were investigated for subsequent designs, but Bell engineers Kenneth Anick and Bob Lichten deemed them unfeasible compared to experience with the 15-3 project. Technological advances One of the major problems with the early tiltrotor aircraft designs was that the drive shafts carrying power from the fuselage out to the wingtip rotors, along with the gearbox and tilting mechanisms at the wingtips, had substantial loads placed upon them and were heavy. They were transferring large amounts of power and torque long distances for an aircraft power transmission system. A 1515 experimental aircraft introduced a major design concept advance. Instead of engines in the fuselage, a 1515 moved the engines out to the rotating wingtip pods, directly coupled to the rotors. The normal path for power was directly from the engine into a speed reduction gearbox and into the rotor propeller without any long shafts involved. There was still a drive shaft along the wings for emergency use to transfer power to the opposite rotor in case of engine failure, but that shaft did not normally carry any power loads, making it lighter. The tilting engine concept introduced complexities in the design of the engines and engine pods to be able to shift from operating horizontally to operating vertically. Those problems were addressed fairly early in the 1515 program. In the late 1960s and early 1970s, NASA and other researchers worked extensively on theoretical and wind tunnel tests of various rotor pods. Two companies were involved in the research and proposing designs, Bell Helicopter and Boeing VTOL. The focus was on tilt rotor pods, integration of the tilting rotors with the wings and fuselage of the aircraft, and studying the airflow as the rotors tilted. Tilt rotors with fixed rotors and with folding rotors were investigated. 1515 project What was to become the 1515 program was launched in 1971 at NASA Ames Research Center. After preliminary work, a competition was held to award two $0.5 million research and development contracts for prototype designs. Companies that responded included Sikorsky Aircraft Corporation, Grumman Aircraft, Boeing VTOL, and Bell Helicopter. R&D contracts were issued to Bell Helicopter and Boeing VTOL on October 20, 1972. The two companies' design proposals were delivered on January 22, 1973. Competing designs, Boeing proposed a design, Model 222, in which the engines were in fixed pods at the end of each wing, and a small, rotating pod with the rotor was slightly closer to the fuselage on the wing. This design simplified the engine design by keeping it horizontal at all times without having very long drive shafts to the tilting rotors. In the Bell design, Bell Model 301, the whole wingtip pod rotated between horizontal and vertical, with the engine and rotor assembly fixed together within the pod. This simplified the power transmission, but it had more complicated requirements for the engine design and was probably slightly heavier than the Boeing proposal. After a review of both proposals, NASA selected the Bell 301 for further development, and a contract for further R&D was issued on July 31, 1973. Extensive engineering and testing took the next 4 years to complete the development of the aircraft. The first of two Bell 15-15s, tail number N702NA, first flew on May 3, 1977. After minimal flight test at the Bell Test Facility, the aircraft was moved to Ames Research Center in Mountain View, California, where it was then mounted in the large Ames Wind Tunnel and tested extensively in various simulated flight environments. For the U.S. Department of Defense Joint Service Vertical Takeoff Landing Experimental Aircraft Program, Bell Helicopter and Boeing VTOL teamed to submit a bid for an enlarged version of the 15-15 in 1983. The Bell-Boeing team received a preliminary design contract that year, which led to the Bell-Boeing V-22 Osprey. Flight testing. Following wind tunnel and flight testing by Bell, the aircraft was then moved to NASA Dryden, which is at Edwards Air Force Base in the California high desert. The 15-15 flight testing continued expanding its flight envelope. It was able to successfully operate in both helicopter and normal aircraft flight modes and smoothly transition between the two. Once the aircraft was considered sufficiently tested, it was returned to Ames Research Center for further testing. The 15-15s were deemed sufficiently tested, as one aircraft was taken to the 1981 Paris Air Show for demonstration flights. The New York Times praised its performance. And if ever there was a lovable plane, it is the Bell 15-15. The machine, the hit of the show, performed a series of maneuvers including bowing to the crowd. Over the next year, Senator Barry Goldwater, Navy Secretary John Lehman, and other officials were offered guest co-piloting flights to promote tiltrotor technology for military development. The 15-15s were a standard demonstration in the annual summer air show at the co-located Moffett Field Naval Air Station for several years during the 1980s. Both 15-15s were flown actively throughout the 1980s testing aerodynamics and tiltrotor applications for civilian and military aircraft types that might follow, including the V-22 program. FAR Copyright DAR Copyright Ration or Copyright Ronautique International classifies the 15-15 as a rotodyne, and as such it holds the speed record of 456 km per hour, and the 3 km and 6 km time to climb. Further testing the first 15-15 prototype aircraft, N702NA, was transferred back to Bell for company development and demonstration use. On August 20, 1992, the aircraft crashed while being flown by a guest test pilot. He was lifting off for a final hover when a bolt slipped out of the collective control system on one pylon, causing that rotor to go to full pitch. The aircraft rolled upside down out of control and crashed inverted. While significantly damaged, the aircraft was largely structurally intact and both the pilot and co-pilot escaped with only minor injuries from the crash. The cockpit of the aircraft was salvaged and converted for use as a flight simulator. The second 15-15 prototype, N703NA, was used for tests to support the V-22 Osprey military tiltrotor program and Bell Augusta BA-609 civilian medium tiltrotor transport aircraft. It continued in primarily NASA test operations until September 2003. The shortest takeoff distance was achieved with the nacelles at 75 degrees angle. After N703NA was retired from test operations, it was donated to the Smithsonian National Air and Space Museum in Washington, D.C. The 15-15 was flown cross-country from Fort Worth, Texas to the museum before being decommissioned for display. It is now on display at the Stephen F. Udvar-Hazy Center at Washington Dulles International Airport. Specifications. Data from NASA SP 2000-4517, General Characteristics, Crew, 2, Length, 42 feet 1 inch, 12.83 m, Wingspan, 57 feet 2 in with turning rotors, rotor diameter, 25 feet, height, 12 feet 8 in, airfoil, NACA 64A015, empty weight, 10,083 pounds, max takeoff weight, 13,000 pounds, power plant, 2A, Evo Lycoming LTC 1K4K turboshaft engine, 1,550 shp each, engine power ratings, 1,550 shp normal takeoff power, 1,802 shp emergency power. Fuel weight, 1,436 pounds, performance, maximum speed, 300 knots, stall speed, 100 knots when in airplane mode, range, 445 mi, service ceiling, 29,500 feet, disc loading, 13.2 pounds FTA squared, power loading, 1.35 kilograms per kilowatt, hovering altitude, 8,800 feet out of ground effect. See also, related development, Bell 15-3, Bell Boeing V-22 Osprey, Edgar Stoursland AW609, aircraft of comparable role, configuration and era, Canada CL-84, Sikorsky S-69, Sikorsky S-72, related lists, list of VTOL aircraft. References, notes. Bibliography. External links, image of 1515 in hovering flight.